Hello everyone, welcome back to this amazing platform of Infinity Learn by Sri Chaitanya. Lovely students, in this class we are going to continue the discussion on transport in plants. This session is going to be very important and fundamental for your NEET exam. Why? Because in this session I am going to discuss plant-water relation. The very first topic in this is water potential. Believe me students, even after completing this chapter, revising it, learning it multiple times, students still struggle on what is water potential. Fundamentals of water potential are still somewhere not clear in most of the students, right? So here I am on this platform of Infinity Learn to help you in understanding and clearing your concepts related to water potential. So let us start this class students, and yes, obviously before starting I would love to tell you, do visit to our website infinitylearn.com and check out the amazing courses that we offer there. You can use those courses or subscription at straight 40% off by applying the code Kiran40. So my lovely students, do consider applying the code Kiran40 while taking those subscription available on infinitylearn.com website. Right students? I hope this much is clear to all of you. Now let us start. So what are you going to get in this session? Let us discuss that, and then I will start with the very first thing, that is the definition of water potential. So see here my students, first I will give you a brief idea about what water potential is, and then I will explain you what is solute potential and what is pressure potential. Right? This solute potential and pressure potential are the components that determines the value of water potential. And finally, after explaining all these things, I am going to give you summary, the important key points on which you can solve your MCQ questions related to this topic, right? So I hope this much is clear to all of you. Hello KR, hello Sunil, very warm welcome, and I would really appreciate if you do participate in the class. Let us start with the very first thing, that is water potential. So let us check out students, what is water potential? Here it is. So see students, first I will talk about how water potential is represented, right? So let us discuss few facts about water potential, and then we will jump into the concept, the reality, the meaning of water potential. So water potential, it is expressed as psi W. So what is water potential? It is expressed in terms of psi W. This is how it is expressed. Second thing, water potential is expressed or measured in terms of pressure. It is measured in terms of pressure, right? So it is expressed in terms of pressure. Please remember this very important point. Next thing that you need to understand over here is, let us talk about the unit. Let us talk about the unit. So what is the unit? What is the unit of water potential? So see here students, the unit of water potential, the unit of water potential is pressure, right? And you know, pressure is expressed in terms of Pascal, right? In terms of Pascal. And more precisely, I should say it will be, the water potential is measured in terms of megapascal. So these are the few important points, few important facts that you need to remember. Water potential is expressed in terms of psi W. Secondly, water potential is measured in terms of pressure, and the unit is going to be similar to the pressure, that is Pascal, and more precisely megapascal, right? So I hope these facts are clear to all of you. Now the time has come to understand what exactly water potential means. So here I am students giving you the definition of water potential. I will provide you the most easy and simplest explanation of this concept. So do listen to each and every word very carefully. Do not get distracted, right? So here I am giving you the definition of water potential. So water potential, it is a fundamental concept. It is a fundamental concept given to determine the net direction of movement of water molecules. So what do I mean by this line, students? Very simple. In this first line, I am trying to explain you why this water potential concept is introduced in your syllabus. Why are we studying water potential? So water potential is one of the most fundamental concepts with the help of which we can determine the direction in which there will be net movement of water molecules. Now these water molecules can be moving like even within a cell or between two cells, right? So what is water potential? It is a fundamental concept that helps in determining the net direction, the direction in which there will be a net movement of water molecules. So this is the utility or usage why this particular concept has been coined, right? And why are we studying? Now, secondly, let us start with the term itself, water potential. What does potential means? It is a normal English word. Potential means ability. Potential means ability, right? Ability. So when I say water potential, that means it is the ability of water molecules. Water potential, listen this very carefully, it's going to be quite amazing. Water potential is the potential of water. It is the ability of water to do what? To do some useful work. What is a useful work? To move from one point to another. I repeat myself, what is water potential? Here I am giving you the most easy and simplest definition of water potential. Water potential is the ability or potential of the water molecules to do some useful work, that is moving from one point to another. So what is water potential? It is the ability or potential of water molecules to do some work, to do some useful work, Now what is this useful work? This useful work can be, I am giving you the example of what can be a useful work. Example, moving from one point to another, either within a cell or between two cells. Right, my kids? Here I am coming back to this definition for all of you. What is water potential? It is the ability or the potential of the water molecules to do some useful work, that is moving from one cell to another or between or within a cell. For example, this is a plant cell and here water molecule is present. For example, here this water molecule is present. Now, if this water molecule show movement and changes its coordinate from this point to this point, this is also what? Work done by this water molecules. And for this to happen, water molecules possess potential. water molecules need to have energy or ability. Same, now this water molecule can also show movement from this cell to another cell. What is this? When water molecules move from this point to this point or between two cells, they are showing or they are doing work, and for that work to take place they need to possess ability or potential known as water potential. Simple? Let me know in the comment section if there is any doubt till now. Any doubt till now? Let me know in the comment section. Any doubt till now? Okay, then I would love to move forward. See here students, next thing that you need to understand over here is according to thermodynamics. According to thermodynamics. Now my kids, I am going to connect this water potential to the most and basic concepts of your chemistry. All this is chemistry only. What I am discussing, water potential itself is a biochemistry topic, right? We are going to connect biology with chemistry over here, right? So, I am using the most fundamental concept of your chemistry to relate water potential. Very simple. You must have studied in your 11th class chemistry classes, right? Physical chemistry classes. So, according to thermodynamics, it is the free energy of a substance that can do useful work, right? So, according to thermodynamics, my students, a substance has two types of energy, bound energy and free energy. Now, if this substance, for example, here substance is water molecules. So, if water molecules need to perform some useful work, that is moving from one point to another within a cell or between two cells, then this molecule, this water molecule can use only the energy which is present in free form and not the bound energy. So, bound energy of water molecules cannot be used to do any kind of work, that is movement. So, the free energy that is associated with the water molecules is going to help them to move from one point to another. That is the work done, right? So, according to this statement, we can say, therefore, say that free energy that therefore we can say, what we can say? I want to change. Where is my pen over here? Just give me one moment. Just give me a minute. Yeah, I got it. So, we can say that free energy of water molecules is water potential. Water potential. I really hope students this much is now clear. So, according to thermodynamics, if you say that a substance can perform work using its free energy, that means if water molecules are showing movement, if water molecules are doing work, that means it is the water potential, it is the ability of the water molecules that is helping them to perform work, that is helping them to move from one cell to another cell or within a cell. That means who is helping the water molecules, who is giving this ability or potential to do work? It is the free energy of water molecules. Hence, you can say free energy of water molecules is nothing but water potential. So, free energy and water potential are synonymous, okay? I hope this much is clear to all of you. Now, students, the next question that should strike to everybody's mind is, from where does water molecules get this free energy? Who is or what is the reason behind free energy possessed by water molecules? Now, this is our next discussion. we are going to talk about what in a water molecule provides free energy to them. So, free energy of water molecule, right? Free energy of water molecules. See my kids, free energy of water molecules occurs or is possessed. Free energy in water molecules is possessed due to two reasons. Free energy of water molecules is due to two reasons. What are the two reasons? The reason number one, pay attention, it is the kinetic energy. It is the kinetic, what is happening? Just give me one moment. It is the kinetic energy. It is the kinetic energy of water molecules, right? And second thing is my lovely kids, it is what? It is the physical pressure. Physical pressure applied on water molecules. Applied on water molecules. So see my kids, these are the two reasons because of which water molecules possess what? Free energy. One is the kinetic energy and another is the physical pressure. Now let me show you or throw some light on these two topics. How kinetic energy affects free energy of water and how physical pressure applied on the water molecules is going to affect the free energy of water. So this is what we are going to discuss, right? So see here students, let us talk about kinetic energy. So see students, let us talk about kinetic energy first. Kinetic energy of water molecules. And you must be knowing with your basic knowledge of science, what is kinetic energy? The basic way or the most simplest way in which you can present kinetic energy is half mv square. Simple, half mv square. This is how you represent kinetic energy. So see students, water either present in a physical system or in a biological system. In both these systems, water molecules will be in motion. They will be in random motion. For example, you can consider this is a cell or this is a biological system or physical system, any system, right? And if this system possesses water molecules, these water molecules will be in continuous motion. That means they are going to possess some velocity. And since by virtue of possessing this velocity, each and every water molecule is going to have or possess kinetic energy. And since these molecules are in motion, since they possess kinetic energy, hence they have the ability to move from one point to another within a cell or from one cell to another. Hence kinetic energy increases the ability of the water molecules, increases the potential energy of the water molecules. So what you can conclude over here is, my kids, please notice this very carefully, that is greater is the concentration of water molecules, greater will be the water potential, right? Greater is the concentration of the water molecule, greater will be the kinetic energy also, you can say, and therefore greater will be the water potential. Therefore, greater will be the water potential. I repeat myself students, if concentration of water molecules is is large or greater in a system, in a cell, that means that particular system or cell is going to have greater number of water molecules. That means it is going to have greater amount of kinetic energy, and hence there will be greater amount of water potential. So increase, I repeat myself, pay attention, increase in number of water molecules in a system is going to increase the kinetic energy of the system, and hence there will be increase in the water potential of the system. So please notice this, students, how kinetic energy is affecting water potential. By increasing the number of water molecules, there will be increase in the kinetic energy of the system, and hence there will be increase in the water potential of the system. It can be a biological system like cell or any physical system as well. I hope this much is clear to all of you, my kids. Next what we need to understand is physical pressure. Physical pressure. So see here, students, let us consider this to be a cell. Let us consider this to be a cell, and this cell has water molecules in it. So by increasing or by applying pressure on this cell, what will happen? The water molecules will tend to come closer. So whenever you apply pressure on a system, you tends to increase the energy of the system. You tends to make the system unstable. So whenever you're going to increase the pressure, or apply the external pressure on this system, the water molecules are going to come closer, and hence there will be repulsion between the electron density of each and every water molecules. Remember, water molecules is made up of oxygen and 2 hydrogen atoms, right? So they do possess an electron density over each and every water molecules is going to possess some or the other kind of electron density. So when they are not under any pressure, each and every water molecules are present with respect to each other at a distance where they are stable. They neither get too much attracted, neither get too much repelled from the surrounding water molecules, right? But when you increase the pressure over a cell, you are making the water molecules come closer. As a result, there will be interaction between the electron density of the respective water molecules, and as a result, there will be increase in the electronic repulsion between the water molecules. You are making the system unstable. You are filling energy. You are filling the potential energy in that particular system that can be a cell. So by increasing the pressure, you actually increase the energy, the free energy of the water molecules that can be utilized to do some work. That means hence you are going to increase the potential of, water. So conclusion, what is the conclusion? The conclusion is, by increasing or by applying pressure, there is increase in the free energy of the water molecules. Hence there will be increase in water potential, right? Increasing the pressure, increasing the free energy of the water molecules, hence increasing the water potential. So till now, students, you must have understood the role of physical pressure and kinetic energy on free energy of water molecule, and it is the free energy of the water molecules that is termed as water potential, right? So increase in water potential, my students, increase in water potential or increase in the free energy of water molecules is going to reflect an increase on the water potential as well. So next thing that we need to understand over here is, let us understand, student, what should be the movement of water molecules. what should be the movement of water molecules. So see kids, movement of water molecules is always from a region of high water potential to a region of low water potential. So till now, after understanding the effect of kinetic energy and external pressure on the free energy of water molecule, that is actually going to reflect on the water potential as well, we can conclude that the movement of water molecules takes place from a region of high water potential to a region of lower water potential. So this is one of the tips that you need to follow while giving the answers. Next students, next one we need to understand is, till now we understood the effect of kinetic energy and pressure. Now here we are going to discuss about what is the effect of adding solute on water potential, right student? So see here my kids, I am going to explain, or I am going to give you a very simple explanation over here. Please notice this. Please notice this very carefully. Dear, whosoever is asking what is pressure potential, I am going to come on that. You need to stick to the video, stay connected, and whenever it will be the right time, I will introduce what is pressure potential, right? So see here, first I am going to discuss the effect of solute and then I am going to come on pressure potential. So see students, what is this? For example, this is a beaker A, right, and this is a beaker B. This is a beaker B. Let me make it a little proper from this portion. This is a beaker A and this is a beaker B. Right my kids, this is a beaker A and this is a beaker B. Now see here students. So number of water molecules, say for example here there are 100 water molecules. Here also there are 100 water molecules. So the concentration of water, and consider that these two, right now they do not look same, but you need to consider that these two beakers, or you can consider them as two cells also, right, as two cells also. So these two beakers or these two cells have same dimensions, right, and have same number of water molecules. That means concentration of water here and concentration of water molecules here, in both the condition it is going to be same, right. This one is pure water, but here I have added some salt in it, NaCl. So that means this water molecule is going to have Na plus Cl minus, as well as it will have water molecules, right students? This one is pure solvent, this one is solution. This one is pure solvent and this one is solution. So my students, from your chemistry knowledge, this should be clear that whenever you add salt in a pure solvent, what will happen? The salt, for example, NaCl, right, it will dissociate into Na plus and Cl minus, right, and the water molecules, you remember they are polar in nature. Water molecules are polar in nature, right, they are polar in nature. So as a result, what will happen? The negative partial charges, right, with the help of these negative partial charges, water will get attracted towards the Na positive, and with the positive partial charges, the water molecules will get attracted towards the Cl minus, right. So by adding solute, some of the water molecules get bonded with the solute particles. As a result, the number of water molecules that were free in this pure solvent are not equal to the number of water molecules that are freely available in this. Hence, the conclusion is, on dissolving solute in pure water, there is a decrease in number of the free water molecules, and hence there is decrease in the water potential, my kids. Note here that it is the free water molecules that gives the potential or water potential to these water molecules to move from one place to another. So by adding solute, you actually decrease the number of free water molecules available to do the motion. So number of free water molecules in pure water are greater, and number of free water molecules available in a solution, remember both had same number of water molecules initially, but the number of free water molecules available in B or in solution has decreased, hence making the number of free water molecules decrease. That means water potential is going to decrease. So see here students, here number of free water molecules, number of free water molecules are greater in comparison to the number of free water molecules in solution in pure water. So see my kids, there's a very important point that I have placed over here. Please listen to this very carefully. In a pure solvent or in pure water, the number of free water is more. In a solution, the number of free water molecules is less. And by decreasing the number of free water molecules, the water potential also decreases. Therefore, water potential of A is high and water potential of B is low, right? Because this A section or A cell or A beaker has higher number of free water molecules, that means its water potential will be high. It has low or less number of free water molecules because some are bounded with the solute molecules. They are not free to move. Hence, its water potential will be lower. So, in comparison to A, the water potential of water present in B cell or B solution is going to be lesser in comparison to the one that is present in A. So, what is the conclusion that you should draw, my kids? The conclusion is water potential of all solutions, water potentials of all solution are lower than pure water. So please note students, water potential of all types of solutions will be lower than the pure water because pure water has higher number of free water molecules. Next thing that you need to understand over here is the definition. Now let us define what solute potential is. Solute potential is represented by psi s. Solute potential is represented by psi s, my kids, and see here. Please note over here is the magnitude of lowering of water potential of pure water by adding solute is termed as solute potential, right? Also known as osmotic potential. So how do we define psi s? How do we define solute potential, my kids? It is the magnitude by which the water potential of free water molecules has decreased in a pure water by adding solute in it, right? So what is solute potential? In simpler words, I can say it is the ability of the solute molecules to decrease the number of free water molecules, right? And as a result, they decrease the water potential of a solution, right? Always remember one more important point, students, that increasing the concentration, listen this very carefully, increasing the concentration of solute in a solution is going to have a negative effect on what? It is going to have a negative effect on the water potential. I repeat myself, increasing the concentration of a solute is going to have a negative effect on the water potential of a solution. Hence psi s is always expressed, hence psi s is always expressed in negative values, Psi s is always negative. Psi s is always negative. Why? Or expressed in negative numbers. Why? Because increasing the concentration of a solute decreases the number of free water molecules available in a solution and hence decreases the water potential. Because increasing the concentration of solute is having a negative value of water potential, hence psi s is always expressed as negative, as a negative number. So psi s is always negative. Psi s is always negative. And with this you can also conclude, students, that when more is the solute, lower is the psi s, or you can say more negative. I repeat myself, from these two conclusions, from these two statements, we can conclude that more is the solute molecules in a solution, lower or more negative is going to be the psi s. Please remember this. Next thing. Next is yes. So what is the ability of the solute potential? A more concentrated solution can pull water from the less concentrated solution. This is the power of solute potential. Next thing we need to understand is what is pressure potential. Very simple, just it will take 2 minutes to explain, right? So what is pressure potential, my students? Pressure potential is expressed in terms of psi p. It is expressed in terms of psi p, and pressure potential is the physical pressure. It is the physical pressure present on a solution. So whenever a solution is applied, or whenever physical pressure is applied on a solution, pressure potential gets developed. Now this pressure potential is usually positive, but can also be negative. So what is pressure potential? Expressed in terms of psi p, and whenever pressure is applied on a solution, there is development of pressure potential in that particular solution, and increasing the external pressure on a solution or on a cell, increasing the pressure, physical pressure on a cell or on a solution is going to increase the water potential. Please remember. So usually it is positive but can be negative as well. So I can give you some very simple example of positive pressure potential. So whenever a solution is expelled from this syringe, whenever the solution is expelled from the syringe, what happens? The solution that is getting expelled is under positive pressure potential. Similarly, normally the living cells are under positive pressure potential because of absorbing water osmotically, right? So what does these living cells do? They absorb water, they do osmosis, and as a result there is creation of positive pressure potential, also known as turgor pressure. Next example of negative pressure potential is whenever a solution is drawn in a syringe, at that time that solution is under negative pressure potential. And also remember, students, the water that is present in the dead cells of the xylem is oftenly under negative pressure potential, that you also called as tension, right? So these are the few examples of positive and negative pressure potential, right, students? So we have come to the end of this session, where I am going to provide you now the important summary, the important steps or the important points on which, or using them, you can easily solve questions related to water potential. So after explaining and after understanding this whole concept, these are the important facts, or these are the important points that you need to remember. Let me tell you what is the first one. So it is students psi S and psi P. Solute potential and pressure potential are the two main components that determine the water potential of a solution. So psi S and psi P. Physical pressure and addition of the solute is going to determine the ability or potential of the water with the help of which they will move from one point to another. So water potential, psi S and psi P are the two main components, right? So hence, how do we define water potential? Psi S equals to psi W equals to the sum of psi S and psi P. Please remember this point, students. This is how water potential is represented. Psi W equals to psi S plus psi P. Psi S plus psi P makes psi W, right? Next thing, students, whenever a solution is present, under atmospheric pressure, that means no external pressure is applied on a solution. At that point, the pressure potential is 0 and psi W equals to psi S. Psi W equals to psi S because psi P is 0 in the absence of any external pressure. Next thing, students, you need to remember, very important, water always move from a region of higher water potential to a region of lower water potential. Next thing, students, pure water is going to possess the maximum or the highest value of water potential, right? Because it do not have solute in it, which is responsible for lowering the water potential. So it is the pure water that will have greatest value of water potential. And the last thing that you need to understand is, by convention, my kids, by convention, by default, the pure water that is available at room temperature and is not under any external pressure, that means it is available at the atmospheric pressure, the potential or water potential value of such pure water is considered 0. So by convention, water potential of pure water at standard room temperature, which is not under any external pressure, is taken to be 0. So my kids, this is by default, and 0 is the maximum value. 0 is the maximum value of psi W. So psi W can maximum hold value 0, and psi W value of all the solution is going to be negative. Therefore, we can say psi W of all solutions will be negative, because the maximum value that psi W can hold is for pure water and it is 0. So all solutions can possess or will possess water potential value, psi W value, in negative. So psi W of all solutions will be negative. That's all, students, I wanted to explain in this class, and with this example also you can understand. So this is the xylem. Here you can say this is the xylem is at 0 water potential. This cell is at minus 0.1 water potential. This is at minus 0.2 and this is at minus 0.3. Remember, water moves from a region of higher water potential to a region of lower water potential. So the xylem vessel is at higher water potential, that is 0, right? And all these are at lower water potential. Hence there is a direction. So direction of water flow will be from higher water potential to lower water potential regions. I hope, students, this much is clear to all of you. Still, if there is any doubt, do let me know in the chat box. Thank you very, very much for joining this session, students. Give me a thumbs up if you like me and this session, and do not forget to subscribe Infinity Learn by Sri Chaitanya. Also hit the bell icon so that you get notified every time I am going to be live and won't miss any single session in future. Thank you very much, students, for joining this class. We'll meet again. Bye-bye.